Copyright the University of Auckland. All rights reserved. The content and delivery of lectures in this course are protected by copyright. Material belonging to others may have been used in these lectures and copied by and solely for the educational purposes of the university under license. You may record the lectures for the purposes of private study or research, but you may not upload onto any third-party site, make a further copy, or sell, alter, or further reproduce or distribute any part of these lectures to any other person. Failure to comply with the terms of this warning may expose you to legal action for copyright infringement by the copyright owner and/or disciplinary action by the university.
Nah, it's no worries. Should I just start whenever?
Yeah, just start whenever you want.
Hey guys! Hey guys, my name's Thomas and I'm part of CISA. So tonight we've got our relaunch night. It's at 4:05, 4:70, 6:30 p.m. Come along, there'll be free pizza, and you can collect your t-shirts if you haven't done so already, and also stickers. And also just come along, hear about what we're going to do this semester. There's going to be sporting events, there's going to be volunteering events, and there'll be real-life interactions with people from the industry. Come along, learn some stuff, and see what we're going to do this semester. Cheers, guys.
Okay, so let's make a start today. How many of you got the course book? Or right, okay, so about half. So that's about the same as last year. So a lot of you guys are quite happy with the electronic documents. If you want to teach me how to use it, that'd be great. Anyway, so here's the 2020 course book of CIVIL211. So it continues off from where Quincy and Lucas would have taught you, but we're mainly talking about beams in this course here. Now, can everyone hear me? Can't hear me. Okay, is that better? All right. Okay, so if you can't hear me, just tell me, and I'll increase the volume somehow. So I've got your year one course book from Jason Ingham. So there's a lot of stuff here on beams, bending moment diagrams and things like that. So that's mainly what we'll be covering here. So we'll be giving a recap on that stuff. You'll be having some revision, and then we'll get onto the more complicated stuff. Okay. Any questions so far? So a lot of students find this course to be, I forgot the word, but it's not difficult. It's another D word. Yeah, forgot that word. Yeah, destabilizing or something. So something along that sort of word. So it's not difficult. So I would say it's a bit like riding a bicycle. You need to, once you learn how to ride the bicycle, everything's fine. But for me to try and teach you or coach you how to ride the bike without you actually having a bike and just sitting in the lecture theatre, that's difficult, or that's troublesome. Okay, so there's a big spectrum here of students. So a few years ago, first lecture, guy came to me at the front and said, "James, I flicked through this course book last night and I can do every single question." So, you know, I'm a bit stunned. So I said, are you repeating the course? He said, no, I just flicked through the course book last night and I can do every question. So at one end of the spectrum, that's where some people are. On the other end of the spectrum, there are students who have repeated this course 3 or 4 times, which implies they failed 3 or 4 times. Not many, but I get to know who those students are. Generally, they work very, very hard. They come to me with solutions for everything in the course book. And for some reason, when it comes to the exam day, they just can't pass. And the amazing thing is that on the day that they do pass the course, they flick me a text and they say, James, I passed, and I can't believe the grade. I got an A+. Is there a mistake? And I say, no, there's not a mistake. So that's the 2 different ends of the spectrum. And all it means is that some people take a bit longer for the concepts to sink in. What I would say is this course is probably, in terms of a conceptual jump, this one is probably the biggest conceptual jump that you will have in your 4 years at Auckland. After this course, things become more design-orientated, but there is quite a big conceptual jump here, and once you get through it, it's fine, okay? So it's not difficult, it's just a bit troublesome, and it can take time. So if you feel that you're one of those, and it may take a bit of time, the one thing that you shouldn't do is try to cram. So I'm a champion crammer, I think. I've lost count the number of times I didn't sleep before the exam because I was just busy all night cramming. For this course, you can't cram. You either understand it and get an A+, or you don't understand it, and no amount of last-minute cramming is going to help. So all I say is do what the students seemed to do last year. They seemed to be very diligent last year. You just have to pace yourself slowly, do a bit of work each evening, and over the 12 weeks, by the time you reach the end, everything will be sweet. Okay? All right, so it's just about pacing yourself going through stuff. So I've printed off some stuff on the front. So the first thing is I've said where the class test will be, and that's because a few years ago a student called me and said, where's the class test? And they didn't know where it was, so I printed it on the front page where the class test is, which will be on the 31st of August. In terms of conceptual understanding, we've created over the years with a lot of students these online quizzes. So the purpose of the online quiz is basically to step you through the conceptual jumps, and hopefully things will be very clear. Hopefully things will be quite clear at the end. So there's 2 quizzes. There's quiz 1 and there's quiz 2. And I've put the due time is at 6 a.m. So I was going to put 12 midnight the night before, but I've put 6 a.m. on that day, okay? So that's when the quizzes are due. And on the day that this quiz is due, on the 31st, that's also going to be where the class test is. So it's all been planned because going through the quiz will help prep you for the class test. So I'm basically setting the same things on the same day, all right? So the quiz, when it's released, hopefully it's been released already. You guys see student view on Canvas. I can't see what you see, so you let me know if there's any problems. Flick me an email, and I'll get one of my TAs to sort it out because I'm not very good at computers these days. So there's 2 quizzes, and those are the 2 due dates. So lectures. 4:05 to 4:55 in this room on Monday, Tuesday, Wednesday. I'll just explain my life schedule, and then it might make a bit sense. I do the drop-off for my kids in the morning, so I can get to uni about 9. I've got 2 offices, one office in Newmarket, that's my main office, and I've got an office here. I drop my kid off around the corner from here, so absolutely no problem for me to pop in at 9 a.m. or 9:30 and meet any of you who have any problems going over any conceptual problems. It just really doesn't cost me any time. So anyone who wants to meet me any morning, just send me an email and I'll we agree a time and I'll turn up and I can spend whatever time you need. I've got to pick my kid up at 5:15, so I need to be out of here pretty fast. So I'll try and finish the lecture maybe about 4:50, maybe 4:45. Allow 10-minute questions, and then I have to leave. But if you want to get in touch with me outside those times, that's fine. Happy to Zoom, happy to FaceTime, can do anything. You can call me on my phone anytime. If you want to meet, no problem at all. So if you've got any problems, just give me a call. So I'm doing this not because I love you guys, but because it just doesn't build up the pressure. So if one of you has a problem, you can't resolve it, come and talk to me. Then you'll tell your friends what the answer is, less pressure on me. So by trickle feeding any problems, I'm actually saving myself time. All right. So I put my office hours. You can meet me in the MDLS at about that time. I'll give you my phone number later on. You can get to me by email, just send me a text. That's no problem. They've just given me an office in the tower, so I might just switch the location. But my main office is in Newmarket. Okay. So if you want to meet me, yeah, so there's the instructions. Just send me an email or whatever. The MDLS is new to this university, so there are some inductions that you need to do in order to be safe in the MDLS environment. So those hopefully have turned up on your Canvas. If they've not turned up on your Canvas, it's just a 10-minute quiz. Don't worry, just flick me an email and I'll get it resolved. So any problems, just flick me an email. So within the MDLS, as I said, this course can have some conceptual hurdles which you need to overcome. So I've talked to my TAs. I've got 3 TAs. Any of them can meet you in the MDLS any morning and just help you play with some models, because playing with some models may help you overcome faster any conceptual hurdles. So if you wanted to play with any models in the lab, that's one of my TAs. Just email him the night before, and he probably just lives down the road from here, so he'll turn up and spend whatever time you need, if you need help, playing with any props or any lab equipment. So that's our Puya Lofty Rad. If you look in the course book, there will be tutorial sessions. My TAs will run these tutorial sessions on demand. So you can see me when you like, just send me an email, no problem. If you want to talk to my TAs outside of the MDLS, then there's that Friday session. You can just email them and they'll arrange to talk to you one-to-one to help you overcome any conceptual problems. So this course is all about concepts, a bit like the geotechnic course that you're doing. So they can either talk to you face-to-face on the Fridays or through Zoom. So they'll be pretty flexible, and I'll be pretty flexible as well. Okay, any questions so far? Okay, so that deals with the first page. So this is what we'll be covering in the course. So I probably spent last year, I probably spent the first 6 weeks on sections 1 and 2. These are like the building blocks. So if you've got the concepts, fully in, or you really get the concepts, actually section 5 and section 6. If you look at section 5 and section 6 now, you might think this looks pretty bad. Actually, to get from 0 to end of slope deflection problem, that's a conceptual jump. And to get from the slope deflection problem to understanding section 5 and section 6, that's a smaller conceptual jump. So the way I've paced this in the past is that I've tried to make sure that everyone, 99% of the class, can get up to the slope deflection method and be able to execute that well. And then once you get to that stage, then doing the virtual work, doing the statically indeterminate structures with flexibility, even though that looks really horrible now, just looking at it, it's actually a smaller conceptual jump than being able to go from now to being able to do the slope deflection method. So we've got a topic on buckling, which is a bit separate from that, and there's also a section on shear. So I understand Lucas and Quincy took you last semester. They may have stepped you through some of the buckling and shear, but I know they didn't finish it because they've told me. So I have to finish it with you to complete your education. Because a lot of you, or some of you at the end of this course, will just go to the environmental engineering stream, which means that if you graduate after year 4 and change your mind and want to become a structural engineer, because you've passed this course, you have that license to become a professional engineer in structures if you wish. So we do need to make sure that course content is finished in terms of buckling and shear. So it's exactly what we did last year. Quincy did a bit, and then I took you through to the end. But that's why there's a bit of repetition of the notes. What we did last year, I talked to the class reps. So again, talk to the class reps if there are any problems. But I moved the shear right to the end because you've already done half the shear. And actually, the shear isn't so difficult. And so it's a bit about timing. You'll have a lot of class tests, not from this course, but from other courses, and other courses will be putting pressure on your time. So I'm just trying to move the shear to the end where you may be a bit freer or maybe a bit more busy, and so it's less of a problem dealing with the shear at that stage. So there's a Dropbox link. So if you click that link, my TAs will be uploading solutions. So there's no point in hiding the fact that I have solutions for everything. And if I try to hide the fact I've got solutions, you can talk to last year's students and they'll give you all the solutions. So there are solutions. What I've found works better is to release the solutions in stages. So yes, if you want all the solutions today, you can have them today. Send me an email, you'll have them all today. But I think it works better if the whole year works together and goes through each of these bits together so that you're in sync with everyone else and having the same discussions. After all, that's how engineers work. Engineers are trained. You're trained with a mentor in a design office in the traditional way, and a lot of that training is through discussion. Because frankly, reading a course book, unless you're Quincy or the A+ guy, I don't see, it's very difficult to understand what's happening. Okay, so there's a code. My TAs will be releasing the solutions in stages so that you have a look, try it, then when you're ready to look at the solution, it will be released. But if you wanted any immediate solution, just email Catherine, who's provided her email address there. Okay, any questions at this stage? So that's the course notes. So here's the weekly calendar. So the only thing, so there'll be lectures, there'll be 3 lectures here. Each of you is different. All the lab sessions, all the lab sessions where you can either talk to me, talk to the TA, or play with some kit, that's up to you. They're all optional, so everything's optional. There's some students who don't need it, some students who need it. So if you want it, it's there. If you don't need it, don't worry. Okay. And as I said, the tutorial session on Friday, it runs on request. Just email the TAs, they'll turn up, or they can Zoom with you anytime that's mutually convenient. Okay, any questions? Okay, so here's the provisional course schedule. So like I said, if you want to find me, just contact me by email or send me a text and you can meet with me. And I'm just saying what's compulsory and what's optional. And if you've got this course book printed in red, it will probably say where the class tests are and when the Zorro activities are due in. So that deals with that page there. So so that's me up there, and that's my mobile. So very happy if you want to call me. I've had students call me asking me where the class test is, or they don't know where something is. So no problem, just give me a call at a convenient time for me. And if there's no reply, just send me a message to ask me to get back. That's my Zoom meeting room. So if I say we can't resolve this over the phone, can we try by Zoom? Just click there and we can talk in Zoom. I can use my camera, try and explain. Doesn't work, then of course we can meet in person. In terms of TAs, I've got 3 TAs. I've got Zoe, and I've got Catherine and Puya. So the first 2 are PhD students with me in terms of structures. So Zoe and Catherine had been through the course 2 years ago, so they know exactly what's in the course book, and they helped me prepare it. Puya is an Iranian student. I would imagine he's from the top university in Iran, and he was probably top in his year in Iran. So if you've got any really meaty, really interesting problems, also try Puya. Okay. So again, give the lecture rooms, and then just stressing the tutorials are optional and the labs are optional, but you can meet me anytime you want. In addition to that, there's the Part 2 Assistance Center. So you can go to the Part 2 Assistance Center, where there will be students from last year who did the course last year, and they will be there to assist you. So as I said, sometimes you just can't understand the concepts, and the way to resolve this is by talking to someone. So if you feel more comfortable, go to the Part 2 Assistance Center, and for 3 days a week, starting from week 2, there will be students who passed this course last year who would be able to talk you through any problems that you may be facing. Okay. So each year things change. I now understand there's a free online beam frame calculator. Some students would have told me about it last year, which seems a lot better than the one in previous years. So there's a online beam frame calculator which you can use to solve the questions in the course book. Plot the bending moment diagrams, plot the shear force diagrams, and get the reactions. Obviously, you won't be able to take that to the exam with you. All right? Okay. But you can use that to check the solutions or to make sure that everything's going fine. So next page on this. This tells you about the frame calculator. So it gives you different options to plot the bending moment diagrams, because the problem is, in sometimes if you read a textbook written by a mechanical engineer, he may draw the bending moment diagram like that, which would just give a lot of you a lot of problems. So we've tried to be consistent in how to plot the bending moment diagram, and so I'm plotting it exactly the same way that Lucas and Quincy would have taught you last semester. We plot as civil structural engineers on the tension side, and I'll be explaining that later on, that there's no sign convention, and that's just how it's plotted. So here would allow you to toggle between different bending moment diagrams if you wished. And the way I describe the shear force diagrams to be plotted, I say the shear force diagram is plotted in the direction of the actions, which means you've got a 10 kilonewton load downwards. Obviously, there's 5 kilonewtons going upwards on each side, which you can see there. So if you put the length of the height of that is 5 and the height of that is 5, then you just trace that around going down the beam. So from here down to there, that's a drop of 10. And then you're constant because there's no change in shear, and then up back to equilibrium for the last 5. So the convention, as shown here, is how I expect you to show your bending moment diagrams and your shear force diagrams when you do your final exam and when you do the class test. So when I was an awkward student, I didn't understand what my lecturer was saying, so I picked up a textbook. Textbook plotted bending moment diagram that way, textbook plotted shear force diagram that way. So when I submitted my exam, I had it in the opposite convention. So he gave me full marks. He shouldn't have. He should have failed me instantly, because I've put myself out of sync with what he's teaching and what the rest of the class is doing. And that means that conversations with other people become more difficult, because you're using mental you're having in your head, when you talk to someone, to keep on flipping the side of the bending moment diagram. So for this course, I'll give you 0 marks if you don't abide to that sign convention. Okay. Okay, so let's continue. So there will be some simultaneous equations that need to be solved. So if you have trouble solving a simultaneous equation, just put it into that thing and it will give you the answer. All right? And then another thing to solve. Okay? Now, we come to Piazza. So I've asked the TAs to check Piazza regularly. I've asked the Part 2 Assistance Center guys to monitor Piazza as well. Some of you guys will like answering other people's questions on Piazza. There's always some students who do, and that's great because when you try and get leadership positions in your future life, when you're working as engineers, the people who can answer questions and explain things to other people, they're the ones who do well. So it's good to learn how to explain stuff. So some of you students like answering questions that other people pose. So post on Piazza, post as much as you can, and we will try and get your questions answered on Piazza as much as possible, so that you don't have to have an interaction with someone if it's unnecessary. And again, the QR code for the solutions is there along with the Dropbox link. If you send an email to me or to one of the TAs, just put CIVIL211 question as the subject, and then we won't lose the question. I get so many emails each day, it's unbelievable. So you just put CIVIL211 question as the subject, and it's less likely that I'll miss the email, or one of the TAs would miss the email. So when posting on Piazza, try and be very clear. Don't say, I don't understand this. Put some screenshots, put some pictures. If you can explain what you don't understand, we can try and resolve that problem through Piazza a lot easier than if you just say, I don't understand. Okay? So, and sometimes I can't resolve the question over Piazza, so I say to the student, come and meet me, and I'll talk you through it, because sometimes it's a bit more difficult. And yeah, I'm happy to receive phone calls, especially when I'm driving the car each day. I'm about 3 hours in the car, so you just call me when I'm driving my kids home, and happy to talk. So, the course philosophy and the assessment. So when I was an undergrad, about 25 years ago probably, and it's the same in most universities, they would say 20–25% of the students who do this course fail. So that it's got quite a high failure rate traditionally in most universities. So a lot of things have happened in terms of technology since then. I didn't have any labs when I was a student. There was no Piazza, there was no YouTube, there were no TAs. With technology coming in, the fact that everyone should be passing is just a question of putting some time over. I think the failure rates have been about 5 or 4% for the last couple of years. You guys can check the statistics. But in the old days, normally about 25 to 30% of the students would fail, which doesn't really matter. You just retake it and come back, and that's no problem. Okay, so I've got 2 quizzes now. In real life, sometimes you're working with an architect and there's a competition and you're competing for a project, and then in the competition they'll give you a deadline. So if you submit your entry with the architect for the competition and you miss the deadline, your entry is not counted. So that's just how it works in real life. So I've been a bit flexible in previous years, but being flexible costs me a lot of time. So I'm just saying this year, if you don't get your quiz in on time, I would just prorata the mark as I feel fit. All right? Okay? So you've got plenty of time. You've got until the 31st of August, but there are always like 10, 15 students, and they email me and say, sorry, James, I forgot that the Zorro Q was due in. That's why I've shoved it in on the front page. Okay? So you've got plenty of time. You can repeat the quiz as many times as you want. The instructions are quite clear. For each quiz, if you get if you get 70% or more on each of the quizzes, you will get 7.5%. So if you get 71% on all of the quizzes, you will get 7.5%. If you get 100% on all the quizzes, you'll still got 7.5%. If you get 65% on all the quizzes, then I will do what I feel. Okay? All right. So, okay. So before I would be pulling out, So before I would be pulling out the records and then, just making sure that you've logged in. The quiz is in the cloud. It's linked to Canvas. Every time you log into the quiz, I can pull out the data. So every mouse click you do on the quiz, I can see if you do the mouse click or not. All right. So it's in the cloud. Don't worry. Everything's safe. You're not. The cloud is not going to fail in terms of a technology blip or something. Once you've done the quiz, there's a 2-hour time lapse before your mark is reflected in Canvas. So just be patient. You finish the quiz, you got 90%, you look in Canvas, it doesn't say 90. Don't stress, just wait. And 2 or 3 hours later, it will say 90%. And you've got until 31st of August. So don't worry at all. Okay? So, the course will consist of lectures, demonstrations, self-study problems, and piazza for discussion, and then there will be the final exam. And then these here are the learning objectives, which again you can see on Canvas. Basically, we're making sure you can plot a bending moment diagram. If you can't plot a bending moment diagram, please come back and repeat the course next year. If you can plot the bending moment diagram and other things are not so right, it's okay, you'll probably get a pass. All right, so the main thing is being able to plot the bending moment diagrams. And then the course outline, basic skills. I used to have a basic skill test. There's not one anymore. Qualitative analysis of beams. So quantitative is when you calculate the numbers. Qualitative is as long as you know how it should look. So if you've got a system like there, you've got a load going down there, you should know that the bending moment diagram is going to look like that. That's qualitative understanding. Quantitative is when you work out the numbers, but qualitatively you should be able to tell that this is hogging above the line and that this bit here is sagging under the line. So things like that, and when you go for job interviews, they could just sketch something out for you, and if you can do it, you'll probably get the job over someone else who can't. All right, so this obviously is a statically indeterminate problem, so I'm assuming as of now that you don't know how to mathematically solve a statically indeterminate problem. The way to solve a statically, so if you've got a beam like that with a roller, point low, you know the bending moment diagram is like that, but you knew what the reactions were at the start, and then from the reactions you get the bending moment diagram. When we solve the statically indeterminate problem, we are working out the bending moment diagram, and then we work back to work out the reactions, because you can't work out the directions directly because there aren't enough equations of equilibrium that allow you to solve it. So that will become clearer later on. But some students in the past on the day of the exam said, I don't understand why we can't just work out the reactions for that straight away. And if you think you can, you've got a big conceptual misunderstanding and probably would fail the course. To solve a statically indeterminate problem, you need something beyond what Quincy and Lucas have taught you. Okay? So, in terms of recommended textbooks, this is the textbook that I really recommend. David Braun, Understanding Structural Analysis. So he's probably the pioneer in terms. He's probably the pioneer in terms of explaining about deformations. So you can see there a frame with it being deforming. So if you can't understand me, which is quite okay, it's quite natural to want to jump to YouTube videos. He's got some YouTube videos there. So you can do a search for him on YouTube. You can look at my webpage, just Google me, UOA, and I've put Dr. David Braun's YouTube videos up on my webpage, and he will talk about how these problems are solved. Okay, so for me, this one is the recommended textbook, Understanding Structural Analysis, which I've indicated as that one there. Okay. When it comes to other stuff, like shear and buckling, so if we go back to the course outline, if you go to the course outline, you'll see we'll be doing stuff on shear and we'll be doing stuff on buckling. The course notes are taken from Megson. So what you see in this course book is taken directly from Megson. And in my opinion, Megson has the best explanation over other textbooks. Other famous, very famous textbooks is this one, which is Timoshenko and Gear. The problem with this book is that these guys are mechanical engineers and they're American, which means they're using different sign conventions for plotting, and they're probably also using inches. Okay? So this book is great. It does use a different sign convention, sorry, not sign convention, it uses a different plotting convention from what we're doing in this course here. So I would advise you, stick to Braun if you've got any problems, and stick to Megson. But the best way to resolve any problems or any issues that you have is come and talk to me, and come and talk to the TAs, and talk to your friends, and resolve the problems verbally. Okay, so that's what it is in terms of recommended textbooks. So let's have a look at the assessment. So flicking through the course book, for example, we may have a question here. Sometimes I've got a YouTube video on it. So sometimes I have a YouTube video. I don't want to bore the majority of you, but sometimes my explanations can go on for 3 hours, and the students who get it straight away don't want to listen to 3 hours. Some students want to listen to the 3 hours of boredom, whatever. So sometimes I've got very detailed videos. So in class, I would try to minimize the class time so that the students who just need an explanation and don't want to watch videos can immediately see the solution. Other times, some students want to see videos. So my TAs will be creating videos as well during this course. So there's some videos, but I'll go through it in class, but not in the same detail as the videos. And then here are the questions. So each of these questions, there's a code. So the first question is BD B1, BD B2. When you go to the Dropbox link here, that's how you will find the solution for these. So we'll be releasing these in stages, not immediate, so that you have a go, and then the solutions will always be there if you need it. All right? So that's the problem sheets for the basic skills, and full solutions for all of these will be provided. Now let's continue to flick through. So there's some basic skill tests, and I said this year you guys don't have a basic skill test, but in previous years I've had a basic skill test, so everything is here. Everything that I've given out before as a test is included in the course book. So all the midterm tests are here, and solutions by this code, which you'll be able to go through. And then all the final exam questions are also given here. So you don't need to go through previous year's exam papers and look for them. Everything that's been given for the last 3 or 4 years is all given in the course book. Now, this bit is the slope deflection method, which I'll be getting onto. And for this section, and for all the other sections, there's something called basic problems. If you can't solve the basic problems, really come and talk to one of us. then there's something called advanced problems. So there's basic problems and there's advanced problems. When we go on to the next section on Euler or on buckling, which you can see from here, there will be basic problems, there would be advanced problems, and there will be what's known as exploratory problems. So you flick through the notes or plagiarize from Megson, so you don't need to buy Megson. And then basic problems, which are easy or should be easy, advanced problems, which are a bit more advanced, and then you will have what we termed the exploratory problems. So the exploratory problems are to help distinguish the A students from the A+ students, for example. So you can pass the course completely just by being able to do the basic and advanced problems. Don't worry about the exploratory problems unless you're really trying to top the year. Okay? So that's the definition of basic, advanced, and exploratory problems. So exploratory problems are a bit more difficult to solve. Okay, so everything in the course book. Now, you flick to the back of the course book, and you will probably see the 2018 exam. So the 2018 exam is here. So look at the marking. So let's just say 10 marks for a basic problem or a basic advanced level problem, and then 15 marks in total, and then 5 marks for an exploratory level problem. So I would consider this one here to be an exploratory level problem. So you're not going to fail the course if you can't solve this under exam conditions. So standard examination technique is just get all the easy marks in the exam. So again, easy marks here. For that one, 10 marks. Another 10 marks easy, and something like that one may be a bit more troublesome. So yes, you don't need to be able to do the exploratory level questions to pass the course. Now, the next question that students always ask is the formula sheet. I've not changed the formula sheet in many years. So if you email me what is the formula sheet for the midterm test and what is the formula sheet for the final exam, I'll send it to you, but it will be almost exactly what's here at the back. So if you want to know what formula sheet will be provided to you in the exams, just flick to the back, and if I make any changes, I'll make sure that those changes are explained to you in advance. Okay? So, same thing with the 2019 class test, with the 2019 paper. Maybe a few more difficult problems. So I would call that one an exploratory level problem. And when there is an exploratory level problem, I will tend to allocate fewer marks to it. Now, on the 31st of August, at 6 o'clock, you'll be sitting the 2020 test. I try not to change the words. I'll just change the question. So I'll try not to change the words, but I'll change the question, of course. So this is the test that was sat last year for 2019. So it's not. So you can see the mark distribution and you can see the question. I'll tell you the question, but not give you the pictures before the test, so that you don't get confused. In practice, I would expect you to be able to do this test in 1 hour, but I want not to put any time pressure on you. So I've allocated 3 hours. So you come, you do the test, hopefully everything goes to plan, and when you finish, maybe after an hour, you just leave your test script on your desk and just walk out. those who want 3 hours can just stay, okay? So you don't need to feel under any time pressure for the class test. Okay, any questions at this stage? So last year I was in class and I was trying to explain a concept, and then I said to the class, "I'm so sorry, I can't draw it." And then I realized I could draw it, I just had to bend something. And after bending it, I was able to trace the shape. So maybe I said I can't draw the deformed shape for this, then I realized if I put that down, I could draw the deformed shape just by tracing it. Okay. So after that, I said to myself, can I use 3D printing to help make some models? So I know from my own undergrad experience that sometimes you just get a bit confused, and if you play with a model, just put some load on, you suddenly understand what's happening. Does that make sense? All right. So models are very important, and if you come to the MDLS sessions, you will have models that you can play with. For example, a model like this one here. Okay. So you'll be able to play with the models and play with things physically. So after that lecture, I said to Puya, my PhD student, can you please print for me some model parts? Because I saw that if I demonstrated it in class, the students seem to get it faster. And if you get it faster, that means I can go through the material faster. So sometimes I slow down quite a bit because I can see faces that look very confused, so I slow down. But I found that once I showed the model last year, everything was fine, okay? Or everything was able to go a bit faster. So here's a model, and those of you who were a bit observant, when you saw the course book here, and you look at the last year's exam question, which would be 2019, for the exploratory part, you can see the question is to draw the deflected shape of that frame, which is actually quite difficult. So some of you, if you caught Quincy, some of you would find that blindingly obvious. If you caught James, it's maybe not so obvious. Okay, so what I did here was that we 3D printed some parts. So you can see at the bottom here, this is what's known as a pin. So you can see the pin, and the pin allows rotation. And then you can see this other pin here, and this other pin allows rotation. So at the bottom of the frame, we are allowed rotation. So one misconception of students is that they're a bit unsure about the rotations. But you just play with the model, and you can actually see what's happening. If you put a load down here, you can see that the frame deflects, and you can see the deformations. So an interesting one is to stick the load sideways. So I'll do that there. And then you can see the deformation, and you can see the point of contraflecture at that point. So you can see by pushing the frame across. After all, as engineers, we're concerned about buildings. We're concerned about beams. So you can see here there's a point of contraflecture at that point, where the bending moment diagram switches from the tension side here to the tension side there. So just by looking at a model, you can sort of suss out which way the thing is going to deform. And if you put the load on slightly offset, then you will see that the frame sways. So a lot of students, when they see this one there, they think that these points are fixed and that it just deflects like that, whereas actually a frame is able to sway, which is what's called a sway frame. So this is just a joint in space, and you can see the frame swaying from side to side as you put the load on. Okay. So I'm a bit of a believer in models, and 3D printing technology has sort of provided the means to be able to create a model and to be able to demonstrate it in class. So right here we see a simply supported beam, and you can see this end here, because this is pin and this is roller. This is not roller here. You can see as you apply the load, it moves to the left. If it didn't move to the left and it was pin-pin, then you've got a chain or you've got catenary action. This one here, that's not a pin, that's a fix, or what we call a fix. And if you pull down the fix, and if you pull that down, you can see there's a difference in shape. And actually, it's here where the bending moment diagram is, is largest. So these are the models that we've designed, and I've printed this in SLS. So what I was sort of saying to myself, and I may get into a bit of trouble later on, not sure if I will, but I was going to say that anyone who wants to and can be bothered to print a model, I will allow you to bring that model to the class test and to the exam. All right? So if you fancy printing a model, then that's, we will allow you to bring it to the exam or to the class test. So, so that's all within reason. So I'm saying I thought printing a model may be difficult, but we have the MDLS and they have 3D printers here. But I printed this in SLS, which is a different material. 3D printing, firstly, I can see a lot of ways to improve the design after printing it the first time. There's a lot of easier ways to do things than what is done here. But I've provided you with these model files if you like. But if you try to print these files, they will not print, because what's available in the MDLS here is not SLS, it's a different material. It's a bit of a cheaper material. So with this one, we print it in SLS. My TAs had to take pins and they had to do some sanding. They had to pick out some parts, so it's not gonna be beautiful. But if you wanted to, you can try a print, and you are more than welcome to change the design if you want to. But obviously, I can't say bring whatever you want into the exam. I need to see what you propose to bring into the exam. I don't want you bringing in a 12 feet 3D print or a 3D print of yourself or something. I don't know. So if you fancy bringing in a 3D print, we need to know what you're bringing in before. So on the Canvas page, once you've done your 3D print, if you wish to bring it to the exam, just upload either the model files or upload the upload the model files, upload some pictures. My TAs would just check it and just make sure that you're not bringing in anything stupid. So I would suggest that if you did want to do that, then something about this size. I would like it to be this size, not so big. So the MDLS, if you find the right people in the MDLS, they will cut this for you. I've given you all the electronic files that are needed to create this in SLS. As I said, the printing material here is different. If you want to, you're more than welcome to talk to the MDLS technicians, and they will help you print something of your design or a modification of this design. But you will not be able to print exactly what I have, because this is a different material. Okay, so I'll leave that for now. See you tomorrow at 4 o'clock.
Bye.